Welcome to This Explainer. Today, we're tearing into AS/NZS 3000-2018, better known as the wiring rules. Now, forget the idea that this is just dry, bureaucratic red tape. It's really not. This document is literally our frontline shield of safety. We're going to look at how Section 1 provides the master blueprint for keeping immense electrical power from turning into an absolute disaster. Okay, let's dive right into this. To unpack this standard today, we're going to follow a 6-step roadmap. 1. The wiring rules explained. 2. Scope and application boundaries. 3. The fundamental safety principles. 4. Defending against electrical hazards. 5. Design and equipment selection. And 6. Means of compliance.
All right, kicking things off with part 1, the wiring rules explained.
So this joint Australian and New Zealand standard, it isn't just a polite list of suggestions. It's a mandatory framework built on literally decades of engineering knowledge, failure analysis, and tech progress. Which brings us to a direct question for you. What exactly do the wiring rules protect us from? Think about it. If this standard is our shield, what on earth is the sword? What specific targets is this document trying to keep safe day in and day out? Well, Section 1 actually gives us the exact answer right out of the gate in Clause 1.1. The intention is to, quote, protect persons, livestock, and property from electric shock, fire, and physical injury hazards. It's about saving human lives, for sure, and preventing buildings from burning to the ground. But notice that surprisingly specific inclusion? Protecting livestock. That's right, agricultural animals are explicitly protected here, because an electric shock in a damp dairy shed is just as lethal as one in a residential bathroom. It's a brilliant reminder that this standard is dealing with the real, messy, living world. Which naturally brings us to part 2, scope and application boundaries. Now, what's really interesting here are the exceptions. On one hand, the standard covers general electrical installations in our homes, commercial buildings, industrial sites, the usual suspects. But on the other hand, it specifically does not cover things like ships, aircraft, or the internal wiring of telecommunication networks. It also completely excludes massive electricity distribution grids. Why? Because those realms have their own highly specialized engineering codes. The wiring rules draw a very distinct line in the sand. They strictly govern the safety of the power after it reaches your property's electrical installation. Moving right along to part 3, the fundamental safety principles. We're taking a bit of a macro to micro approach here. The absolute foundational backbone requirement of the standard is basic protection. In regulatory speak, this means preventing contact with parts of the electrical installation that are live during normal service. Put simply, it's the physical barrier, the engineered enclosures, the insulation, that keeps users totally safe when the system is operating exactly as intended. Let's see how this builds into our next core concept, which is fault protection. So what happens when things fail? Fault protection steps in to guard against dangers from contact with exposed conductive parts, like, say, a metallic appliance chassis. Normally, that chassis isn't live, but it could suddenly become live during a fault condition. When you combine basic protection for normal use with fault protection for systemic failures, you paint a complete, fail-safe picture of shock defense. All right, part 4, defending against electrical hazards. Clause 1.5.1 gets incredibly practical here, explicitly grouping the chaos of the real world into 3 major urgent risks. 1. Shock current. That's electricity actually passing through a human or animal body. 2. Thermal effects. This basically means stopping electrical arcs from starting a fire, igniting combustible materials, or causing severe burns. And 3. Explosive atmospheres. If you're installing equipment in an area filled with flammable gases or combustible dusts, a single tiny spark could cause a massive explosion. No joke. The standard mandates absolute protection against all 3 of these catastrophic outcomes. And honestly, the threats don't stop there. Clause 1.5.14 forces designers to anticipate external influences. We're talking about Mother Nature and the environment. You have to protect your electrical work from extreme weather, water, seismic activity like earthquakes, corrosive fumes, and heavy vibrations. It even explicitly lists flora and fauna, which, let's be real, is just a very formal bureaucratic way of saying you have to design your systems to stop a local possum or a rat from chewing through your wires and burning the house down. On to part 5, design and equipment selection. Mitigating these extreme external influences and terrifying risks requires very intentional design and strict equipment selection. But crucially, once the design is built, it has to be verified. Clause 1.8 lays out a strict, deliberate sequence for this. First, inspect visually. Second, test rigorously with specialized equipment to verify the requirements. And third, And this is the absolute golden rule: compliance must be completely verified prior to the installation ever being energized and placed into service. You test it before it goes live, never after.
And finally, Part 6, Means of Compliance.
So how do you actually legally prove your design is compliant and safe? Well, the NZS 3000 standard uses a brilliantly structured two-part system, and this brilliantly illustrates that exact structure. On one side, Part 1 outlines the safety outcomes. Think of this as the mandatory destination, the fundamental principles and hazard defenses we were just talking about. On the other side, Part 2 is the deemed to comply section. You can think of this as the prescriptive, highly detailed map to get to that destination, dictating everything from exact wire sizes to precise earthing methods. So, the crucial point is this. The standard states that installations complying with the prescriptive step-by-step methods in Part 2 automatically satisfy the essential legal safety requirements of Part 1. Basically, if you follow the detailed map perfectly, the law guarantees you have safely arrived at the destination. It completely removes the guesswork for everyday electrical work. But that leaves us with a final, provocative thought to wrap up our explainer today. What if you're building something entirely unique? If you deviate from the standard's prescriptive map in Part 2, can you still legally prove your specific design is safe? The short answer is yes. Clause 1.9.4 allows for specific design. But, and it's a big but, if you don't use the map in Part 2, you as the designer take on the immense legal responsibility to prove from scratch that your custom design still meets all the fundamental safety outcomes of Part 1. It is a really heavy burden, and it highlights just how gravely the standard treats electrical safety. Thanks for joining me on this deep dive into the shield of safety that is Section 1.